Hi, I want to talk about Riemann sums. I'll explain what they are in a moment, but let's look at the problem we have here. It says one attempt to find the area under a curve is to break the curve into different geometric figures that we know formulas for. We've already seen that. This usually produces an overestimate or an underestimate. So when we had straight lines, we could get an exact area, but now that we have a curve, we can't really break it into true figures. So it's common to use rectangles. Sometimes we use trapezoids. If you watch some of the Khan Academy videos, you'll see that, but we'll mostly use rectangles here in the examples. So here's a problem. It says approximate the area between the x-axis, which if we look at the graph is down here, and g of x equals 2 to the x, which is the blue line curve here, from x equals negative 2 to x equals 2. So between these two parts, which is the shaded region. And it says use a right Riemann sum with 4 equal subdivisions. Okay, so what we're going to do is we're going to break this up into 4 equal rectangles or 4 equal parts across the x-axis. So if we start at negative 2 and go to positive 2, then this one it's very easy to say that they would each be 1 wide. Okay, so let's go down and see what we're looking at. So as we break this into 4 rectangles, it says to use a right Riemann sum. So a Riemann sum is basically dividing this up into figures that we can work with. Usually rectangles, sometimes trapezoids, there's other methods, but a right Riemann sum takes the right endpoint of the curve. So instead of looking at where negative 2 has a height, we come over to where negative 1 has a height and where 0 has a height. So we're taking the right side of each block. So the blocks were negative 1 to negative 2. So in this case, we use the negative 1 for the height. From negative 1 to 0, we use the right side, which is the x equals 0. So we have the figures here. So it's 4 equal parts, and we've used the right side of each endpoint for the curve. So we've got rectangles, which are length times width. So let's keep going here. So as far as the length times the width, in this case I've called it width and height. The width for each one of these is 1, and the height is whatever the function value is at that point. So down here I've got a little chart, and I've plugged in the values. So the endpoints are from the right side, negative 1, 0, 1, and 2. So I'm talking about the height of this yellow rectangle, the height of this green, red, and orange. So with that down here, I've plugged all those values into 2 to the x, which was my function. And when I plug in the 2 to the x, I get these y values, which are the heights, 1/2, 1, 2, and 4. Each one of these was a width of 1. So basically what I've got is a width of 1 across the x-axis and a height of 1/2 on the y-axis for the first yellow rectangle here. The green rectangle has a height of 1 and a width of 1. So length times width gives me the area of that rectangle, so I've multiplied all those out and I add them up, so I should get a total of 7.5. So this is the right Riemann sum. So if we took the rectangles here that I have and added their areas all together, we would get 7.5. Now obviously some of this comes above that curve. If I drew that curve across here, you would see that I'm going above it. So this is an overestimate. So we're kind of just approximating right now. So what we've got here is 7.5 for the right Riemann sum. And a Riemann sum is just the total of all those figures added together. But in this case, it's an overestimate. Okay? So we know that the area under that curve that we started with way up here should be less than 7.5. Okay? But the right Riemann sum does give us 7.5. So if I was to draw a figure that used the left side, because this graph could go any different way, and if we're going to overestimate, it seems that we could also underestimate. You see I've got here, I didn't make a table for it, but negative 2 would be the point that we'd use to get the height of the first rectangle, which if I plug negative 2 into 2 to the x, it would give me 1/4. So this first one would have an area of 1/4, but each one of these does not even cover the whole area of the curve. So if we did use a left estimate on this one right here, we would be underestimating. So whatever this total would give me from here, it would not be the true area on the curve, but it would be less than. And there's other ways we could estimate this. If you go into Khan Academy, the section I've asked you to do does right Riemann sums and left Riemann sums, and that's all I'm going to ask you to work on. But there's also videos that I'd like you to watch to just kind of see where we could use the midpoint, which basically means we could run this up to this first one here, up to -1.5, whatever that would be. Over here, the green rectangle would go up to 1/2, so we kind of cut along here. That might seem like a better estimate if we use the midpoint of all these figures. And then trapezoids, which trapezoids would go along a diagonal, which still would not be correct. It would use the left and the right endpoints to draw a straight line, which in this case would still be a overestimate, I believe. But there's other ways to get a little bit more accurate here. But that is what we need to estimate the area under this curve.